In this worksheet, we're going to identify the statement as either linear or exponential growth. Some things to keep in mind: linear has a constant rate of change. So it's always changing by the same amount per unit, whatever that unit may be. And then exponential growth is going to have some keywords here, and I'm not going to cover all of them. But if we see something growing by percentage, that's going to be exponential. If it is doubling or triple or cut in half, right? All of those things would signify that this is growing exponentially. I'm going to go through the first 5 of these, and then I'm going to leave the next 10 for you to do. And I'll explain some of these as I go through, so stay tuned as I go through them. So with number 1, I have the bookstore has 5,000 books and is adding 25 more books each month. So this 5,000 is just our initial amount, or the starting amount. The initial amount has absolutely nothing to do with whether the function is linear or exponential. So even though that was some information, it does not help us determine if it's linear or exponential. What does help us is the 25 more books each month. This portion is my rate of change, and it's constant, right? So it's $25 each month. So that's never changing. If I have it in month 2, I will be adding 25 more books. In month 3, I'll be adding 25 more books. In month 4, I'm adding 25 more books. So that rate of change is constant. So this function is linear, and that's how I want you to answer this worksheet. I just simply want you to write linear or exponential in each one of the lines beside the question. Let's move on to number 2. So I have a gym membership is $75 plus $6 each time you use the gym. So once again, the $75 is my initial amount. It does not help me solve anything, and the initial amount might not even be given. But if it is given, it doesn't matter what it is. But then I have $6 each time you use the gym. This is my rate of change. And once again, this one's going to be constant. If it's the first time I use the gym, they charge me $6. If it's the 100th time I use the gym, they charge me $6. So $6 each time I use the gym, and that $6 is never changing with the amount of times I visit the gym. So once again, this is linear. Now I should mention there that my overall cost is changing because it's adding $6 each time, but the rate per visit is not changing. So that's stayed constant at 6. So number 3, your saving account starts at $15. Each month, the amount of money in your account is doubled, right? So keyword here is doubled, right? So $15 is my initial amount. Again, once again, good information, but isn't going to help me. But this is the rate of change, right? So this is what I want to think of here. So how is my account changing? All right, my account is being doubled each month. So if I start with 15 and then it doubles, it goes to 30. And then the next month it doubles, it goes to 60. And the next month it doubles, it goes to 120. If I look at the rate of change each month, and I'll try to do this with the calculator, or sorry, not with my calculator, with my Zoom. All right. If I look at the rate of change each month, the first month it went from 15 to 30, so it increased by 15. The next month it went from 30 to 60, so it increased by 30. The next month it went from 60 to 120, so it increased by 60. This is how much they changed each time, right? So they changed by those amounts. And we can see my change for every month changes as the month goes on. So this one is going to be a exponential growth, and I'm not going to write it all out, and you don't have to either. That's going to be exponential. Sammy's grandfather, let me highlight, sorry, gave him $5,000 to start his college savings when he was 6 years old. The bank pays 2% interest every year. So with this one, $5,000 is my initial amount again, but the rate that is changing is 2% every year. So when I see the word percent, I should think exponential. I'm going to go ahead and write it, but I'm also going to explain to you how it is that All right, so let's say, what is 2% the first year? I'm going to grab my calculator. 5,000 times 0.02 gives me 100. So he started with 5,000, and then in the first year, 2% of that would be 100. So he has 5,100, and that was an increase of $100. And then in the next year, I need to take 2% of what I have in the bank. So 0.02 times 5,100 is going to be 102. So now this is 5202, and I would go so on. But what we can do is we can see that in the first year it grew $100, and the second year it grew $102. So that rate that it was growing was not constant. Anytime we are growing by percentage, it will not be a constant growth from one unit to the next unit. In this case, from one year to the next, it's not always going to grow by that $100 that it grew in the first year. All right, last one for me, and then the rest are going to be yours. So here we go. So a certain type of bean plant grows at a rate of 5 inches every 2 weeks. So my rate, and you'll notice this one does not have a exponential value, or I'm sorry, an initial value. So the rate is changing is 5 inches every 2 weeks. 5 inches every 2 weeks, if we want to think of it as that way, which would be 2.5 inches per 1 week, right? I'm just dividing by 2. I simplified that fraction. So that's 2.5 inches per 1 week. Whether I'm on week 1 or week 2 or week 3 or week 4, it's still growing at the rate of 2.5 inches per week. That rate's never changing. So that is going to be a linear statement. So the rest of them, number 6 through number 15, you can do and submit back to Moodle.